head lecture. In this lecture, we are going to solve problems in for time shifting, reversal, and escape. Okay, so let's get started. So this is my signal y of t, which is x of minus 4t plus 5. So I will take my left hand side approach, this one, LHS. So y of t can be written as x of minus 4t plus 5. Okay, now I will take minus 4 out of my time equation, so it will become something like this. Okay, so what I have to do here is, it is minus 4, so I have to do compressed and reversed by 4. Okay, then what I have to do, delay by 5 by 4. So this is my first operation, this is my second operation. This operation also I can break into two parts. So x of t would look something x of t, then compressed by 4, then apply time reversal. After this, I will apply delay by 5 by 4. This is y of t. Okay, so this is my x of t. It is from minus 1 to 3. This is 1 here, this is t, this is x of t. Now I have to compress my signal by 4. So it will look something like this. Sorry, it is minus 1 here, so it will look minus 1 by 4 and minus 3 by 4. It will look something like this. Minus 1 by 4, 0 and 3 by 4. Then I have to apply here time reversal. So it will look something like this. Minus 3 by 4 and 1 by 4, and here it is t. Then I have to delay my signal by 5 by 4. Delay by signal by 5 by 4 means moving in the right hand direction. So 1 by 4 plus 5 by 4 and minus 3 by 4 plus 5 by 4. So it is equal to 1 by 2. This one is equal to 3 by 2. Okay, so my output signal will look something like this. It is from 1 by 2 to 3 by 2. Okay, now I would like you to approach from right hand side. This is an assignment for all of you. So if you do with right hand side, your equation y of t will look something like this. Okay, if you found any difficulty, you can comment on it. Okay, so this is my second problem. So in this problem, we have given x of t and y of t. We need to find the value of alpha and beta. So let's get started toward it. So y of t is x of alpha t plus beta. Okay, so if I will move from this direction, that is taking left hand side approach, so I will take the coefficient of t common, so it will become like this, t plus beta by alpha. So first I will, now there is an information given in the signal itself. See, the width of my signal x of t here is 8 and width of my signal here it is y of t is only 2. So my signal is getting compressed. Okay, so I can write it down here as compressed by alpha, then advanced by beta by alpha. Okay, so I can write it down as, just wait a minute. So this is my x of t is compressed by alpha, then advanced by beta by alpha. Okay, this is y of t. So x of t here is something like this. X of t is from -4 to 4. This -4, 0 and 4. Then I'm compressing my signal here, so it will look something like this. -4 by alpha and 4 by alpha. This is t. This is some intermediate signal. Okay, then I want to advance my signal by beta by alpha. Advance by signal by beta by alpha means I have to shift in left side. Okay, left side shift. So it will look something like this. That is, I have to do -4 by alpha minus beta by alpha and 4 by alpha minus beta by alpha. So my resultant signal is given in the question itself. So it will look something like this. It is 0 here and here it is -2. So actually this 0 is equal to 4 by alpha minus beta by alpha and -2 is -4 by alpha minus beta by alpha. So we have two equation and two unknown. Okay, so if I will equate 4 by alpha minus beta by alpha equal to 0, then I will get 4 equal to beta. Okay, and if I will equate this part, then I will get -4 minus beta by alpha equal to -2. Then if I will take minus common out here, then I will get beta plus 4 equal to alpha, and we know beta is equal to 4. So it is 8 equal to 2 alpha, so alpha equal to 4. So alpha is equal to 4 and beta is equal to 4. Okay, this is my third problem. In this problem we have given a signal x of t where it is 0 for t less than 3, and for each of these signal we need to find out where this signal goes to 0. So these are my 5 signal. So I had taken a unit step signal. I thought many of you will be aware of this, and if you are not, then we will see this signal in the upcoming lecture also. Okay, so you do not need to worry about this. So let's get started to edit. So the first problem says a is 1 minus t. Okay, so if I will take the coefficient of t here, then coefficient of t here is minus 1. So if I will take minus common out here, so it will become something like this, t minus 1. Okay, so what I need to do here is time reversal, then time delay by unit 1, time delay by 1. Okay, so my signal x of t is something like this. This is my first, this is my second, this is my first, this is my second. Okay, so x of t here will look something like this. X of t is like this. It is from 3 to like this. Then what I have to do? I have to do time reversal. So this. So it will look something like this. This signal is continue here, and this signal is continue in this direction. Okay. Then I have to do time delay by unit 1. So it will look something like this. So time delay by unit 1 means I have to shift my signal in the right hand direction. Okay. So if I need to, so it will become something like this, minus 3 plus 1 equal to minus 2. So my resultant signal will look something like this, minus 2, here it is 0. So this is x of 1 minus t. So x of 1 minus t is 0 for t greater than minus 2. Okay. Now moving towards second question, that is b, x of 1 minus t plus x of 2 minus t. Okay, so we have found out this. Now we need to find out this one. So x of 2 minus t can be written as equal to x of, by taking minus common out here, so it will become t minus of 2. Then I have to apply time reversal, then second time delay. Time delay by 2. Okay, so it will look something like this. This is my x of t here. X of t is from x of t, here it is t. Then I have to do time reversal, so it will look something like this. Minus 3, here it is 0, here it is 0. So this is t. Then I have to do delay by 4. So delay by 2. Delay by 2 means minus 3 plus 2 equal to minus 1. So it will look something like this. Minus 1, 0 and t. This is x of 2 minus t. Okay. Now I had to now now I had to add both of these signals, x of 1 minus t and x of 2 minus t. So this is my x of 1 minus t. It is from minus 2. This is x of 1 minus t, and this is x of 2 minus t. I had to add these signals. So my resultant signal will look something like this. So it will, if this unit is 1 here and here it is also 1, then it will become 2 here, and after this will become 1. So here it is minus 1 and here it is minus 2 and here it is 2 and here it is 1. So this is x of 1 minus t plus x of 2 minus t, and this signal is 0 for t greater than minus 1, it is 0. Okay. So my head is x of 1 minus t and x of 2 minus t. We have found out that x of 1 minus t looks something like this and x of 2 minus t looks like this. Okay. So I need to multiply both of these equations, and if I will multiply both of these equations, then the resultant signal will look something like this. That is okay. So this is x of 1 minus t into x of 2 minus t. So this signal is 0 for t greater than minus 2. This signal is 0. Okay. Then I have to, now my x, now my problem D is x of 3t. Okay. So x of 3t. So x of 3t means compress my signal by, compressed by 3. So x of t is like this. It is from minus, it is from 3. Okay. Okay. So this is x of t. Then x of 3t will look something like this. That is, divide this by 3 equal to 1. So it will start from 1. So this is x of 3t. So the signal is 0 for t less than minus 1. Okay. Sorry, minus 1 now, positive 1. Okay. Now problem E. Problem E is x of t by 3. X of t by 3 means scaling my signal by 3. That is expanding. So it will look something like this. So in this, what I have to do here, it is 3 into 3 equal to 9. Okay. So the signal will look something like this. This is 0. This is x of t by 3. So this signal is 0 for t less than 9. Okay. Thanks for watching this lecture. If you find any difficulty, then you can comment on my blog also, as well as you can comment on my YouTube channel. If you haven't watched my lecture 1 and lecture 2, then please do watch, because those are also a base for this lectures. Okay. Thanks and goodbye.